Coffee stains and chains. I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. LeetCode, beast mode, 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 LeetCode, beast mode. This is not a main thing, really I'm a coder. Coffee stains and chains. I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. LeetCode, beast mode, 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 LeetCode, beast mode.
Day 9 and 10, advent of code. Let's get it. So, for a recap, day 9 we got folded. It was some like math equation. I don't even know how to actually solve it, but a bunch of people on my Discord actually, like a few people solved it and were giving me some good ideas, like some Green's theorem of something crazy like that just to solve day 9. Yeah. Something like Green's theorem just to solve day 9. Yeah, something like this. I mean, it makes their solution does make sense, but yeah, that's I mean, I didn't feel like implementing it. But we're going to get into just day 10 right away, and if we have time, we'll get back into day 9. And so day 10 just dropped. Let me just quickly grab something. I mean, first off, how's everyone's Tuesday going? Everyone's December week going so far? Before we get into this. And how's the audio? Y'all think I'm gonna get folded? Okay, we're gonna lock in. We're gonna lock in to make sure I have my everything's good. Hold up. My lip chat. Getting dry out here. We're gonna go crazy. Who's in here? Say what's up. Don't be shy. What up? Long time. How you been? What up, Austin? Heard that you were on a trip. I'm back. I've been on a trip. I was gone for a long time. How's everyone doing? How's everyone's week? Ramen, what up? Nice to see you again. You ready for day 10? So in October, I had friends visiting, family visiting SF. So and then I went to Orlando and Miami for like for the last week and a bit of October, and then November I was in Mexico, then I was in Vancouver, and I'm back in SF. So it's just been a while, been a lot of stuff. You like SF more or New York? I like SF more than New York 100%. SF is where everything's happening. If you want to grow your career, SF is where it's at. And I like the weather better. New York is a bit like when you're in New York, all the big buildings just surround you is like it's way too congested. I don't know how I wouldn't be able to live there, honestly. But I do like visiting New York, but I'd rather not live in New York. I'd rather go visit New York. I've already visited like 4, 5, 6 times. Hopefully, I thought there was like a bunch of homeless people. Really depends on what area you're in. Like California as a whole is just a beautiful state, and the weather is nice. Like the weather is mild all year. You go to New York in the summer, it's so hot and humid. Right now, it's freezing. In the spring, it's raining. It is a lot more busy, but I don't know. It really depends on the lifestyle you want. But like with what I'm trying to do, SF is the place for me, and everything is happening here in SF. All right. NY is like Toronto 10X. Ramen, you been there? I haven't been to Toronto, honestly. But New York is a very wild place. Damn, did you get the offer at Bloom? Damn, when I did my Bloomberg interview, yo, congrats, man. That's wild. Yeah, I think I remember you said that. When I did my Bloomberg interview, it's during COVID, so they didn't fly me out. I wish. That would have been nice. That was your first time going to New York? I had a Bloomberg offer for new grad as well, like when I was graduating. Are you for new grad or for intern? Okay, sick, 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 sick. Good luck, man. Let me know how it is. Message me. I know a few people who work there. Wow, that's far. Robin, you're pretty good at LeetCode then, huh? Like when I'm doing these questions, you're able to follow along. I remember you were giving me advice on one of the days too. Like in order to get a Bloomberg offer, they ask pretty hard questions. Like the audio is good, right? Yeah, it's good. Yeah. All right, let's get into day 10 advent of code. We didn't do too well on day 9, only had 1 star, but we're going to get day 10 today. Hopefully, we're successful. We have a bunch of people in the chat who are actually pretty good at LeetCode, so they'll help us out if we ever get stuck. But let's get it. Like and subscribe if you're not already subscribed to the channel. But all right, day 10. Let's lock in. Day 10 factory. Just across the hall, you find a large factory. Unfortunately, the elves here have plenty of time to decorate. Or fortunately, the elves here have plenty of time to decorate. Unfortunately, it's because the factory machines are all offline and none of the elves can figure out the initialization procedure. The elves do have the manual for the machines, but the section detailing the initialization procedure was eaten by Shiba Inu. All that remains of the manual are some indicator light diagrams, button wiring schematics, and Joltage requirements for each machine. So we just have a bunch, like a sequence of stuff. The manual describes one machine per line. Each line contains a single indicator light diagram in square brackets, one or more button wiring schematics in parentheses, and Joltage requirements in curly braces. To start a machine, its indicator lights must match those shown in the diagram. To start a machine, okay. Where dot means off and hashtag means on. The machine has the number of indicator lights shown, but its indicator lights are initially turned off. So an indicator light diagram looks like this. Means that the machine has 4 indicator lights which are initially off, and that the goal is to simultaneously configure the first light to be off, the second light to be on, the third to be on, and the fourth to be off. Okay? Let's see. You can toggle the state of the indicator lights by pushing any of the listed buttons. Each button lists which indicator lights it toggles, where 0 means the first light, 1 means the second light, and so on. When you push a button, each listed indicator light either turns on if it was off or turns off if it was on. You have to push each button an integer number of times. There's no such thing as 0.5 presses, nor can you push a button negative number of times. Bruh. So button wiring schematic like 034 means that each time you push that button, the first, fourth, and fifth indicator lights would all toggle on and off. If the indicator lights were like this, pushing the button would change them to be like that. Okay? Because none of the machines are running, the joltage requirements are irrelevant and can be safely ignored. Okay, we could just ignore the joltage for now. Maybe that might be another thing in the future. You can push each button as many times as you'd like. However, to save on time, you'll need to determine the fewest total presses. I'm already sticking some dynamic programming thing. You will need to determine the fewest total presses required to correctly configure all indicator lights for all machines in your list. There are a few ways to configure the first machine. You can press the first 3 buttons once each, a total of 3 button presses. You could press 1, 3 once, and 2, 3 once, and 0, 1 twice, a total of 4. Okay. And you can press all the buttons except 1, 3 once. Okay. However, the fewest button presses required is 2. One way to do this is by pressing the last 2 buttons. So if we press 0, 2. No, I didn't look at part 2. We're on the next question now, Paul. Day 10. Looks like some dynamic programming. The third machine has a total of 6 indicator lights that need to be configured. 1, 2, 3, 4, 5, 6. The fewest presses required to correctly configure it is 2. One way to do this is by pressing buttons 0, 3, 4 and 0 once each. So the few button presses required to correctly configure the indicator lights on all the machines is 2, 3 plus 2 equals 7. Analyze each machine's indicator light diagram and button wiring schematics. What is the fewest button presses required to correctly configure the indicator lights on all the machines? Okay. Ooh, that's... Okay, the input is not too crazy. But we literally need to do it for every single one. Interesting. Robin, go try. You should try it out too if you're on your computer. So, dude, this one from yesterday was haunting me. Have you already looked at this one, Ramen? The L's do have the manual for the machines, but the section detailing the initialization was eaten. Okay. One machine per line. Each line contains a single indicator light diagram, one or more button wiring schematics, and joltage. We don't care about the joltage requirements right now. To start a machine, its indicator lights must match those shown in the diagram. Okay, so it needs to eventually get to this. The machine has the number of indicator lights shown, but its indicator lights are initially off. So an indicator light diagram like means that the machine has 4 which are initially turned off, and that the goal is the first light to be off, second to be on. Okay. So everything. So let's take some notes. Again, not that straightforward right away, but we'll work through it and figure something out. It was hard, huh? I've never tried it yet. So we're gonna be given something like this. Let's look at one input. And we essentially we start with everything off. They said the fewest button presses required is 2. One way to do this by pressing the last 2 buttons. So the fastest way is to go from there's these 3 dots to 0 and 2. We get this. And then to one like this. Oh, sorry. And then 0 and 1 we get what, like something like that. And then that matches. So these are kind of like the options of like combinations we need to do. So one way I'm thinking is Caesar mods in the building. So one way we're thinking is, could you just press, like there's no reason to turn on 3. We essentially have this starting state, and we eventually want to get to some end state, and we just need to follow. It might be like a graph question. Yo, Mod, thank you. Thanks for the $2 gifted. Appreciate you. Mod's funding my streaming career. Let's see. Mod, what are you up to? We're running 2K tonight? So if we do, I guess from the start, let's look at this. I guess like from the start, we have multiple options. We can like push button 1. Say this is button 1, this is button 2, this is button 3, this is button 4, this is button 5, button 6, button 7. One way we could do is like we can try pressing button 1, button 2, like brute force 3, 4, like all the way, all the different options up to 9. I guess like here we can like also push all the buttons again, but it wouldn't really make sense to push the same button again, because then we'll just go back to the same state. But I guess if we get back to the same state, maybe we could just cache that. And like for each one, like if we want to get to this state, we can get to 0. We could store a minimum of how we can get to each state. And if we ever get to a state higher, then we just return. If we can get to a state lower than we did before, then maybe we just keep going. But like the most brute force solution is like avoid getting back to the same state, and like sort of like for each button, like branch out all the different options. Like kind of it's essentially like a brute force, but we need to have a way to like not run it forever. Or I guess we could just brute force the whole thing. But like how do we know when to stop looping? Well, since we're minimizing, if we get to a state that we've seen before, like can we even just do a backtracking? Yeah, let me think about this a bit. So what are the different options? We can when we start with dot 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 dot, we can start with just 3 or 3. Yeah, but there's no point in like pressing it back again, so because we'll just get back. But what if we only had these buttons and we just wanted to get 1 3? So maybe one option would be click, or we just want to get one. Maybe one option is click 1 3 and then click 3 again to turn just 3 off. Then we get just the dot, or we only get this one turned on. Why do you think we only need to press it once or twice? Okay, let's try brute forcing. Let me think of a brute force solution first, then we could figure out how to optimize it. So the main thing when it comes to brute forcing the algorithm right now, like, it could be like a backtracking sort of recursion. And then maybe if we get to a state that we were at before, we just like, what if we get back to a state that we were at before? You don't need to press twice subsequently, but like maybe you can like, maybe there's a case where if you press it 3 times, given some sort of sequence, it might work. Because the way I'm thinking about this is like it's kind of a graph. When you start off on this state and you have multiple branches that leads you into like other states. Like you can get dot 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 hashtag. This is one state. You could eventually get back to this state. But maybe we just store that then we can see. Wait, maybe what we can do is let me think about this. Robin, I'll look at your suggestions in a second after I think about it for myself for a bit. The third machine has total 6 indicator lights that need to be configured. Okay. That's the hard part. Or you can press the first 3 buttons once each. A total of, you can press 3, 1, 3, and then 2. You can press where 0 means the first light means okay. When you push a button, each listed indicator light either turns on if it was off or turns off if it was on. You have to press each button at an integer number of times. Okay. We know for sure. We know, like, one thing we know for sure is we're gonna be able to get. It's kind of like a graph, but we don't want to get into loops. So I think what I'm gonna do to avoid getting into a loop is, yeah, maybe I won't try pressing it twice. More than twice. What happens if you press it more than twice, like 3 times? Will that do anything? Like, will there be a case when I need to push it 3 times? Then we have dot, 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 dot. And my goal is, like, when will I have to push it to get to? So maybe, let me think about this. Yeah, it's definitely not just like a simple backtracking. What's some options? Blanking out. Three. So let's just simulate this just to see what we're working with. So we can start with dot, dot, dot. You can first press the first 3 buttons once each, a total 3 buttons. So we can go 3. That gives us, turns on this. Then we do 1, 3. Sorry, 1, 3. 1, 3. Turns this off. But like our 1, 3, that turns this off. We just do 2. Maybe we could be smart. Like, we only want to turn ones on. We need to look at the ones we need to get in the right place and only click buttons that will lead us towards, like, closer to the result. Because we need to avoid, okay, that's 3, okay. That's example 1. Or you could press 1, 3 once. So you can start dot, 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 dot. You could press 1 and 3. 3. 2 and 3. This turns this off. And 0 and 1. Why does it matter? We already got there. Well, we press 1 and 3. 2 and 3. And 0 and 1 twice. Why would we need to hit it twice? That might be a hint. Okay, that's 4, yeah. Or you can press, that's example 2. Or you can press all the buttons except 1 and 3 once each. So we can start. So we can start with 3, 0, 1, 2. So from each state, let me think. I guess from every state, we can just try every option once. If we go from every state and try every option once, it's going to deterministically get us to a different state. Yeah, we can try for everyone, just try every button once, because coming from, like, suppose we're at this state and we tried all these different options once, it'll deterministically get us to a similar state, or like to like a different state. Then we could kind of maybe just keep tracking a hash map, like the lowest that we've ever seen on any state. And then, like, for every single state, we could just try every single state we've seen, we could just try all of the options. Like, for every single state we see, we can try all of the options, and that's all we need to do. Every time we see a new state, maybe we push it in a queue, and we try all the different states with that option. Yeah, I think that might just be the solution right there. Every time we see a new state, we try all the different button combinations on that state. If we see a new state that we've never seen before, then we add it to some sort of queue. And then we just keep track of, like, for every state that we see, what's the minimum we've ever seen it get there. I don't know if that even makes sense. Does it make sense? Wait, let me think this through a little bit. How long we've been? 25 minutes on this one question. So pretty much what we do is start with starting state. try every button combination on it. If we see like it will generate like X new states. For every new state, we generate we try every button combo on it. It's like a BFS. Do we need Dijkstra's on this? Wait. No, like there's no weights. I think we could just literally do a BFS. And if we just like fan out like that, we're good. Okay. We'll try to like on this small example. So if we have something like this, we'll take no way. I have a fire alarm going off. Not getting out. Okay. Expected. Maybe we could do expected state and just like put a tuple, which is like 0, 1, 1, 0. And then we could do the options. Dude, someone's fire alarm is going off. We can do. This could be the options like this, right? I don't know if y'all can hear in the background, but we're gonna still get through this. So we start with a state of 0, 0, 0, 0. Maybe you just do people are here. Can you hear like the fire alarm going off in the background? I don't know whose is it. Bro, the fire alarm has just been going off constantly. Okay, good. I have like a good background noise. Yeah, Ramen, we could like bit mask. What do you mean bit mask the state? So we start with a queue and like wow. Scene equals set. Something like this. While the length of the queue. What we're gonna do is yeah, you're right. So Yeah, I can try that out in a second. But what we said is what we're gonna do is we're gonna look through the options. So what we're gonna do is we're gonna be like candidate q dot pop left, right? Since we're only we'll do import dq. So this is the first state, and then we're gonna go for every option for option in options. What we're gonna do is we're gonna take like the and modified equals. We're just gonna turn the candidate into a list. Then for elem in the option, what we're gonna do is we're gonna flip it from 1 to 0. Yeah, maybe it's better if we. How do we flip it? Do we have to do like a XOR? Or we'll just flip it if for element like if 0 if 1 else 0. So if it's equal to 1, turn it to 0. If it's equal to 1, turn it to 0. Otherwise, convert it to 1. If it's equal to 1, turn it to 0. Otherwise, 0, then turn it to 1. If tuple, if can modified, in scene, continue. We'll have a distance here. Right? Set distance. Then we'll do q dot append can or modified distance plus 1. There's like we're doing a bunch of conversions, so it might be annoying, but and then we do can modified equals. So let's just turn it into a tuple right away. Distance plus 1. If candidate can did it canned equals expected state break right, this cd data on 3 part for option in options. Let's see. Well, it's supposed to be a tuple. Aren't tuples iterable? Three, okay. Print the options real quick. 3, 1, 2, 3. Oh, okay, that's annoying. Look if it's a tuple. It's gonna turn these options into just arrays. Oh, I see. You're right, you're right, you're right. Smart, smart. I'll probably just like when I do the input. Okay, we're printing out the right result. Let's see if we're... What's the result here? What if we wanted to do one way choose by pressing? Okay. So now we just need to like generalize this input. So what we need to do is be able to like take the input string, split it. Um, I'm gonna grab my code that reads from the input. What? Oh. Test for line in input string. Print the line. Now we're gonna put this all into like some function at some point. Ramen, what do you think so far about the solution? Is this similar to what you would have tried? The line and input string. What the? Why is it all in? Oh, I didn't split it. So what we're gonna do is for line and input string, what we're gonna do is part one or parts equals line dot split by just like we just split by the spaces. And then what we say, what was this? Expected state. Expected state equals parts at 0. And then we have buttons equals parts from 1 to -1. And then we have, what's this last part? Joltage equals parts at just like the last element. So let's just make sure we're extracting the expected state in buttons. Perfect. Now we just need to turn the expected state into what we want. So we just want it to be a tuple like this. So what we can do is parts equals if lm is equal to hashtag, that means it's on, turn 1, else 0. So we just want to create the tuple like this. Oh, and we're gonna go 1 to -1 because we're gonna ignore the brackets. So this is the expected state that we want to get into. Now we want to turn the options into tuples. Wait, what are we doing? Because we're just getting 1 and 3. This is how we're gonna get the buttons. To get the buttons equals, we're gonna get the parts again. When we get the actual buttons, what we're gonna do is we're gonna have an array, like for lm in button string. We're gonna get button int equals lm dot split. Well, we're gonna go 1 to -1, and we're gonna split by comma. Then in buttons dot append, we're gonna turn this into a tuple, and we're gonna put the button int. And now buttons should show up how we want it. For lm for x in. We're gonna convert this. We need integers. Perfect. So now we're gonna call this like BFS, and it's gonna return us the result. We're gonna create a BFS here. We're gonna see our expected state. We're gonna be passed in our options, which look good now. equals range length of expected state. We're going to start this off with 0. We return that to a tuple. So we're just gonna do that, and we're gonna be like, for every line, what we're gonna do is we're gonna print BFS expected state button. Two, 3, 2. Perfect. Now we just add them up. We just add them up like that. Print the result. Now we have 7. All right. Now let's get the puzzle input and see how it performs. Woo! That was quick. One gold star. Let's go. BFS. All right. Dub. Okay, let's try out level 2. Let me get some water. Yo, chat. What do y'all think? That was good. That took me 50 minutes to solve that question, but once we figured it out, code was easy. Okay, take a read at this real quick. I'm grabbing some more water. And I'm happy we got that one. But usually day 2 is the hardest. Yo, were y'all thinking the same sort of thing for when you were looking at it? Ramen, what were you thinking? What was the Bloomberg intern thinking? The cracked Bloomberg intern? All right, part 2. All the machines are starting to come online. Now it's time to worry about Joltage requirements. Each machine needs to be configured exactly to the specific Joltage levels to function properly. Below the buttons on each machine is a bigger lever that you can use to switch the buttons from configuring the indicator lights. Yeah, what were you thinking for that one? Wait, let's look at the Joltage. Okay, that's what Joltage looks like. Each machine needs to be configured to exactly the specified Joltage levels to function properly. Below the buttons on each machine is a big lever that you can use to switch the buttons from configuring the indicator lights to increase the voltage. Each machine needs to be configured to exactly the specified Joltage levels to function properly. Below the buttons on each machine is a big lever that you can use to switch the lever. Below the buttons on each machine is a big lever that you can switch the buttons from configuring the indicator lights to increasing the Joltage level. We have to ignore the indicator light diagrams now. The machines have a set of numeric counters tracking its Joltage levels, one counter per Joltage requirement. The counters are initially set to 0, so Joltage requirements like 3, 5, 4, 7 mean that the machine has 4 counters, which are initially 0. And that the goal is to simultaneously configure the first counter to be 3, the second counter to be 5, the third counter to be 4, and the fourth to be 7. Is this like some backpack problem? The button wiring schematics is still relevant. In this new Joltage configuration mode, each button now indicates which counter it affects, where 0 means the first counter, 1 means second, and so on. When you push a button, each listed counter is increased by 1. So a button wiring schematic like 1, 3 means that each time you push that button, the second and fourth counters would increase by 1. If the current Joltage levels were 0, 1, pushing that button would change them to be 0, 2, 2, 4. You can push each button as many times as you like. However, your finger is getting sore from all the button pushing, and you'll need to determine the fewest total presses required to correctly configure each machine's Joltage level counter to match the specified Joltage requirement. Consider again from an example. Is it just a continuation of the same one from last time? Configuring the first requires a minimum of 10 button presses. Could you do a BFS again? Because a minimum of 12 button presses. One way to do this is by pressing 3 once, 1, 3, 3 times. Okay, we just need to keep clicking them up until they get here. Okay, let's just try brute forcing on this very small example. Day 1, day 10, part 1 done. Why can't we just do the same thing? Eric, how did you solve the first part? Did you also use a BFS? Or you did a backtracking? What we can do is like for the Joltage. Get 1 to -1. don't. Test 10, 11, 15. Let's split. Can we just do this? Trying to do part 2. So what we're gonna do is print the joltage and the buttons option. So we're trying to get to 35471. So we start off with a tuple with everything starts at 0. Then we say scene is at 0. Then we add that. If the expected state does this even end? Oh, does. Oh wait. Is that a for loop? Wait, I'm just trying to think of this. Am I like in a Oh, okay. If candidate modified at the LM is greater than like expected state, we couldn't even get to the expected state. Like, can we just could we just use the same algo as before? But instead of joltage, like we're just bumping up. How can it not can't how can it not find? Oh, because I put like a background noise filter. Cause it's so loud outside sometimes. Can you hear it now? There was a lot of sirens and there was a lot of fire alarms. Okay, let's see what happens after the first loop. Do you use like some matrix multiplication then? Or like, let's see. Wait. Um, what's RRF? And then backtracking for non-pivots. I can't even get my normal solution to work. What kind of... Reduce row echelon. I have no idea what that is, man. Are you a competitive programmer? Y'all see what I'm doing wrong here? Wait, Q. Oh yeah. I remember that. That being like a. I remember that reduced row echelon. Now that you mentioned it. For element option. Oh, this not. If I is greater. Okay, I'll take a look at that in a sec. If Why can't it find on this simple example? What am I doing wrong? So if we're starting with the candidate. It should be like all zeros. Oh, will it ever match? Okay, we'll think about the linear algebra one in a second. But like, if this is gonna return me like 357. Okay, the start should be for I in range. Okay. Honestly, we don't even care about like the joltage on the other. Like we don't. One thing we don't care about the joltage on the other ones because. Let me debug this. Expected state 350. Start. We start with 0, 0. Break after the first loop. Four. Why is my just like my simple equation not working? Print. What am I doing? So what we're doing is we're doing what's the goal? The goal is 3574. Oh, I'm so dumb. There should be a tuple. Holy. So you could tell I'm cooked. Okay, then we're gonna try to figure out what the better solution in a sec. Let's try this. How long is it taking for each line to finish? Oh, it doesn't even get there. Can't even get the first one. Okay, how does the reduced row echelon work? Look at that. Dude, doesn't even finish with the first question. Let's look up reduced row. Bro, what is this? No way. All zeros are at the bottom. Okay. The leading entry, first non-zero in each non-zero row is 1. Okay. Each leading one is to the right of the leading one in the row above it. Okay. I remember this. Each leading one is the only. Okay. Okay. Make the top entry of that column a 1. Use row up to make all that. Where do I perform it though in my algo? Oh my god, this cooked. This is actually cooked. Damn. Eric, you're a legend. Yo, are you part of the Discord? Let's see your code. I'm not gonna. If that's the only way to solve this question, I don't know if I can get it, man. But why do we even need that? Like, could you explain that? It's. Why do we need to get it into that form? Why is it? Like, what are we performing RREF on? Like, are we doing are we doing that reduced row echelon thing on these elements? Okay, that is actually wild. Yeah, but like, what are we performing it on? What's the input to the, like, how do we build up this matrix? Like, what is the original matrix gonna be? Your backtracking solution drops. Interesting. Yeah, I remember this reduced row echelon form, but why do we care each? How do you mean by this? Equals 6. 2x plus 3y plus z equals 11. Negative. X equals 1, y equals 2, z equals 2. So it's like, From okay, let me do debrief on approach for day approach number 1. This is for day 9 real quick. Bro, you know how long it's been since I took Lin Alg? And that was literally my worst grade. Approach number 1. Let's see. There's the raycast thing. Then there's like the Green's theorem. Come. So you're saying for day 10 for part 2, what are people saying? You're backtracking? So basically, what does that say? Yeah. This is the hint I got. It's art. But like, I even forgot what. I need to figure this out. Equals 6. Dude, like I don't know. Paul, I'm gonna catch you in the office and we're gonna talk about this one for sure. I don't get what the input is supposed to be. Damn, they got us again, huh? They got me again. Alright. I think this one is way out of my skill level. I need to go study some Lin Alg. But I'm happy we at least got the first question right, because it's just basic algorithms like a BFS or backtracking. Well, yeah, like what we're gonna do is, I'm not stopping until I solve part 1 and part 2. So if I need to study up concepts, I'm gonna study up those concepts, and then we're gonna attack like the part 2s and figure them out. Eventually, before the end of the year, we're gonna make sure we finish like all these advent of code, and I'm just gonna look straight off like just talking with people and trying to understand their solution. Bro, the math is just cooking me right now. Paul, we need to sit down and just debrief on this. I'm gonna show you the question if you have time. Like, I'm just wondering, okay, what do we perform what do we even perform the operation on? But It's all good. It's all good. We gotta sleep. We gotta get ready for work tomorrow. Gotta be up early. I need to go study some linear algebra. Yo, chat. What should I study before like trying this question again? And I'll go watch some videos on it before I go to sleep. Just like straight up REF. Bro, like I don't know what we're backtracking on. Usually when you're backtracking, you're like trying you have like a state and then you're trying to modify the state, and if that state doesn't lead to a result, then you backtrack. Like what's a state that we're working with? That's the part that I'm like confused about. Yeah, it's cooked. It is cooked. Yo, you want the prompt? If you need to submit like my day 9 part 1, yeah. Yeah, if you want to just like submit my part 1, you can probably. If you want to just like get to the part 2, and then we could just like yeah, chat about this. Rough. Took it L. It's all good. We'll bounce back. We'll bounce back. But we have 2 more days. Hopefully we can collect a couple more stars, and it'll probably be like our best performance ever on Advent of Code. If we're able to get elite. So far we have 18 stars. But then like I'm gonna definitely get all the stars. But we just need to like look up some of those algos people are talking about and really understand it, then try to implement it for ourselves. I'm not giving up though. This has been a lot of fun. Um yeah, thanks everyone for tuning in and helping. I gotta sleep for work. Gotta get some good sleep. Dude, day 9? Okay. Bet. Day 9 part 10, Ramen was like this like the solution. I still don't know the solution. There's been like multiple ways that people have said that they can solve it. Okay, yeah, wait. Eric, so like what again was the solution for day 10? Like what? Okay, Eric, cuz like this is what I'm thinking. When you're doing backtracking, right? You have one state. Like backtracking is you start at like an initial state, and then you could try like different options, and then you might backtrack. Like what's the state here? Do we start with the state of like everything at 0, 0, 0? Suppose, like, let's work with the small example. Suppose, like, this is what we want to get to. Expected, right? Well, that's kind of a small example. Oh, yeah. Suppose this is what we want to get to, right? And then we just start off with 0, 0, 0, 0, 0. Like, what matrix do I even need to create? Like, if these are my options. What's the minimum amount of buttons? What's the minimum amount of buttons we can configure so that all the other buttons are forced? What do you mean that all the other buttons are forced? And what do you mean by configure? What's CSP? Okay. Okay. How, that kind of makes sense, but how would we know that? Or like how does the reduced row echelon work there? Like, yo, even for the first example, it's not even solving. Are these the equations? We can go like, how do we turn these buttons into the equation? Like, basically what I'm wondering is, so you want to set up a specific matrix AX equals B where X is equal to type limits. Dude, that is crazy. Okay, what I'm gonna do is I'm gonna pass this into ChatGPT at some point and tell it to explain it to somebody who sucks at math. and hopefully it'll help me out there. But I think that's good advice. Yo, Eric, are you part of the Discord? You should join in. Everyone's posting their solutions. How did you solve day 9? Yeah, this one got me cooked. I need to figure this out. Yeah, but part 2, how did you solve part 2? Like the different ways that people were mentioning it here was like some compression, flood fill, Green's theorem, ray casting. Guys, crazy. You work with the observation that any line formed by adjacent points can't intersect them. Man, y'all are good. Yo, what do y'all do for work? Are you guys just students? Holy crap. One side of the line is inside the square, one side. At Turu, were you able to solve it? How did you use SciPy? Like, what was your solution? How did you solve it? Bro, don't even worry about it, man. Just being able to figure out any possible way to solve it is already crazy. You don't have to feel bad about it. Let's see how other people are doing. I'm watching people that can't even get part 1, so I'm feeling good. I'm feeling good for just even just getting part 1. But those are just other streamers, and other streamers are usually trash. Except for like some really good ones. I had to. See first scene. Now I gotta edit my thumbnail. So see. Oh, wait, what did you say? Say. Okay, say for a certain target index that needs to be 10. See which button presses affect 0. Okay. Damn, Paul, that's wild. I have to take the shuttle at 8, so I have to be up by 7. I'm not rich like you. I can't just live in the South Bay. I live in the Tenderloin, bro. Yeah, but I'm not as good as my money as you. I blow my money on the stupidest stuff you could imagine. Yo, Paul, we need to think about some projects to work on. Cody G's was saying he's making like 60 grand a month, and he's like some of it off, like he's making like 40 grand a month off getcracked.io. We gotta come up with some products. Yo, we gotta brainstorm. Maybe, yeah, I don't even know. Seems reasonable. I don't think he'd be lying because like his YouTube money sounded proper. His YouTube money, like he wasn't exaggerating his YouTube income. Do it for each target index. Dude, okay, that's sick. Yeah, Paul, we're gonna come up with some ideas in 2026. We're actually just gonna get straight up rich. So he's saying for certain target index 0 that needs to be 10, see which buttons affect 0. Suppose that it's affected by buttons A, B, and E. Do you just need to specify the equation A plus B plus E? Oh, is it like... Yo, suppose this is A, this is B, this is C, this is D, E, F, G. We're gonna say A, three, like what's the equation looking like? Something like this? Like if we say it's A, B, and C, it's gonna be like... Okay, bet. Yo, y'all are so cracked, like being able to watch through your phone and then just like come up with algorithms or explain algorithms. It's actually not. I'm a little bit better than I was last year at LeetCoding, but like still definitely not where I want to be. I'm gonna be spamming code forces next year. Yeah, that's my goal. Yeah, and then you saw my live and I can't even solve it. My bad. Yeah, type in your solution so I get to see like what we mean by A, B, and C right there. I'm editing my thumbnail real quick. Change day 8 to day 10 and change the color. I got cooked. So now I'm gonna make a thumbnail and just straight drop it. Yo, you got this, man. Then what? Okay, cause yo, this is what this other guy was saying. This is the other approach. Like Turu. This is the other approach the other guy was saying. This is. I'll recap it for you. Turu, join the Discord. Are you part of the Discord? Because everyone's dropping their solutions there. But this is what he said. I use reduced row echelon and then backtracking for non-pivots. It's RREF and then backtracking on top of it. What's the scipy function you use? Which scipy function? Nah, bro, you still solved it. I wouldn't even have thought of this. Yeah, which scipy lib do you even use? I got cooked. Like, but like from that other guy, why do we need a backtracking algorithm if all we need to do is just like solve this equation? Is the backtracking algorithm like how you solve this equation? So these affect these. Yo, so what would this eventually shoot out? Because what we need to know is... Yo, I don't even have cursor. Or I don't even have SciPy. Shit. Gotta kill it. Bro, somebody at work was literally talking about this the other day. This mixed linear integer programming. I was like, what? I don't know how to do like, basically to do part 2, I couldn't figure it out, but the chat gave me some good advice. You have to do like some mixed programming. Or you need to basically like, you need to, dude, it's complicated, man. It's complicated. Unless you're good. It's like some linear algebra. Should I just straight pip install scipy here. Wait. How do I how do I do I have virtual how do I capped. Sure. Are you part of the Discord? Hop in the Discord. And we've been just like talking about it in like the daily discussion or like LeetCode daily. Yo, send me the code. Send me the code. In daily LeetCode. Bro, I got a Keytron. I got a Keytron Max or something. Q6 Max. It's expensive, bro. It's like a couple hundred. Alex, man, how you been though? Long time. I got cooked. by this advent of code. Oh, man. It is nice. Can't lie. Break it up into pieces. Okay, send me DM. Yeah, man, it's been a while. I've been taking it. I had a lot of work to do. That's why. So I've been pretty busy with work. What's C? What's C in this equation? Shoot. Yeah, I see. Okay, it works. So there's equations. A, B, C. A, B, B, C, D, E, F. So both these are Yo, Paul, is this still related to like the matrix multiplication stuff that they're talking about earlier? Still the same? Yo, Turu, what do you do? Are you a student? Like, why are these all ones and not like two? Wow, you're a beast. You're a beast. Nice to meet you, man. That's so cool. You're a PM or you're a product developer. That's wild. You're going. That's crazy. You could solve. You could just solve these for fun. Did you do like competitive programming or something back in the day? Yeah, you're a really good coder. Damn. Yeah, I didn't really get into competitive programming, so I'm just trying to like do some catch up now. Yeah, I'll read over this. Okay, I see. That makes sense. That makes sense. Because each of these, because every time you click the button, they just increase by one. Dude, that's so crazy. You probably made a ton of money when the stock went up. Okay. That's so sick how you're doing this for fun. All right, Paul, I'll see you tomorrow for day 11. I have my code up for part 1. So for part 1, I just did a BFS. Turu, did you do the same kind of thing like just a BFS? Turu, this is my code for. Damn, I didn't do bit mask. Yeah, post your code. I'll see how similar it is to mine. But I just did a BFS. How fast were you able to do it? – 6 minutes? It took me like 20 minutes. It's crazy. Okay, I'm gonna need to keep practicing. Alright, Turu, Paul, thanks for hopping in. I'll see y'all tomorrow for day 11. We're gonna try to see how we get there. And last, like, Wow. That's crazy. Yeah, I think that guy sounds familiar. Yeah, this guy sounds familiar. All right, yeah. I'm gonna keep doing this every year, and hopefully I get better and better. Like, this is the first year where I was able to solve like way more than before. So, like, I'm able to solve like the first part of each one, but then starting day 9 and day 10, I started flopping the second one because it just got like I just couldn't solve it. But like, I'm gonna keep studying, and hopefully soon next year be able to handle these. Do you do other challenges too? I want to do some of these challenges year round if there is any. Not obviously not every month because it takes a lot of time, but like every like quarter or something. If there's these challenges, that would be cool. But yeah, thanks for joining in. Hope to see you around on the next one. All right. See you, chat.
This is not my main thing, really I'm a coder. Coffee stains and imitations, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. LeetCode, beast mode, 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 LeetCode, beast mode. This is not my main thing, really I'm a coder. Coffee stains and imitations, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. LeetCode, beast mode, LeetCode, beast mode, LeetCode, beast mode, LeetCode.